talk about arc length, we were already discussing arc measure as the number of degrees between 2 points on a circle. But with arc length, now we're actually going to measure that in terms of inches or feet or centimeters, something like that. So inches, feet, centimeters, etc. For some reason, every book in the world that I've seen uses S for the measure of an arc length. And in order to do that, you're going to have to know, notice I'm drawing 2 radii here, the measure of this angle right over here. And I don't know how much I've shown you guys this. What I'm drawing right now is a Greek letter called theta. And theta is a variable that we use a lot in higher levels of math and science in order to denote an unknown angle. And the formula for arc length makes some sense if you think about it. Arc length, the distance from this point to this point, is a part of the circle's circumference. So I'm actually going to start over here with the formula for circumference, which is 2 pi r. But I don't want the whole thing. What we want is a portion of it. And what we want is this angle right here, which we call theta, out of the entire circle's measure, which is 360 degrees. So this is your formula right here for arc length. Theta divided by 360 times 2 pi r, where r is your radius, and theta is the measure of the central angle, and then of course it also becomes the measure in degrees of the arc that we are looking for. So let's do 2 quick examples with that before we get out of here today. All right, in example A, we're trying to find the length of an arc here, S. So to do that, 3 steps. Number 1, formula. S is equal to a theta over 360 times 2 pi r. Step 2, fill in what you know. S is equal to theta is the degree measure of this arc, which is also the degree measure of this central angle here. So it's 60 over 360 times 2 times pi, and in this circle we have a radius right there of 9 inches. And step 3, evaluate or solve as we need to. What I would do if I were you guys right now is simply go to my calculator and type in 60 divided by 360 times 2 times 9. You can put the pi in if you want, although sometimes it's going to give you a decimal right here. But let's see, that fraction becomes a 1/6 of an 18 pi, and that's going to get us 3 pi inches for the length of that arc. And if we think about that, that makes some sense. Pi is roughly 3, so that means that the length of this arc is about 3 times 3, or 9 inches long. Well, we know that this piece right here is 9 inches as well, and those 2 things that I've highlighted in yellow look like they could be about the same length, so I find that answer pretty believable. If we take a look at B, notice the directions are different. Now we're solving for R here, but we were given the length of an arc right here as 25 pi millimeters. So again, just like we did 2 slides ago, this one just flips things around. Okay, so we are going to take S equals, and again, we're just writing our formula here. This is our roadmap for how to get started. S is equal to theta over 360 times 2 pi r. And in this problem, what's different is that we now know the value of S right here. That was given to us as the 25 pi millimeter measurement. So 25 pi goes here. That equals theta is the measure of our central angle here, which is 150 degrees out of 360, multiplied by 2 times pi times your radius. And r is what we're trying to solve right here. So this one is a little bit more complicated than what we had before. Okay, probably the very first thing I would try to do right here in attempting to simplify this mess would be to notice here that there's a factor of pi on both sides. So probably the first thing I would do is divide both sides of this equation here by 2 pi. Technically that goes all the way there and here. That might make things a little bit easier for us. So that 2 pi cancels with that 2 pi. On the left-hand side, this pi and this pi cancel out, and the 25 divided by 2 is going to get us a 12.5, and that equals a 150 over 360, and now just multiplied by r. Lots of different ways you could do this problem and lots of different orders in which you could do it, but we'll all get to the same spot eventually. The last thing we have going on right here is a fraction, 150 over 360, that's being multiplied by r. So to undo multiplication by a fraction, rather than dividing, what we're going to do is we're going to multiply both sides by the reciprocal of that fraction, which in this case is 360 over 150. Okay, and what happens there is that multiplying a fraction by its reciprocal, well, they simply cancel out completely. So what's that going to get us then? The r is all by itself on the right-hand side, so I'll move that left and get r equals. And now at this point, I would think we would want to grab our calculators as well, and I'm going to type in 360 divided by 150, and then multiplied by 12.5, and that gets me a nice clean answer of 30. And since a radius is a length, our units here were millimeters, and our radius is 30 millimeters. Okay, everybody, so that wraps up 10.6. Let's give that homework a shot and see how we do on that.